Section 3.2, the derivative. The derivative as defined is simple for a function f is called f prime of x, and it is defined by this particular limit if it exists. That is the limit of ft minus fx over t minus x as t go to x. So as it gets closer, what this really is the rise over the run. In other words, the slope of the graph at that particular point. The slope doesn't always exist if your graph is jagged, okay? If you have a corner there, there is no, this limit wouldn't exist, for example. But if a function does have a limit like that at a certain point, we say that f is differentiable at that point, and the derivative is defined by this particular function. Now, if f is differentiable in a certain area, so that everything's going good, then we say that f is differentiable. Now, as an example of it, let's look at a very simple function, such as, let's say f of x equal to x squared. And then let's find out what is the derivative of this thing at any point x. So by definition, the limit, let's figure out what the f prime is, if it exists. Okay, so f prime of x by our definition is the limit as t goes to x of ft, which is just ft is just t squared, because that's that thing. Function f is just x squared, so ft is t squared minus fx, which is x squared, divided by t minus x. Now, do this particular limit, does this limit exist? Well, in this case, it does, because we can simply do this as the limit of, well, difference of squares. It factors into t minus x, t plus x, and over t minus x. And as t is not equal to x, we can cancel this out. So then it is equal to the limit of t plus x as t goes to x. If t becomes x, of course, the answer will be 2x. So the f prime, if fx is equal to x squared, f prime of x at any point of x is simply 2 times x. So that works out very nicely. Now, sometimes, of course, you have functions that are defined by 2 parts. That happens a lot if a function has a jump or some odd thing happening. If the function is defined by 2 parts, to decide whether it's differentiable at the dividing point, at the split point, you simply calculate the limit on each side, coming from each side, and see if the limit is the same. If it's the same, then the limit exists, as defined here. If it isn't the same, then the limit does not exist. Now, another thing I want to mention is that the derivative has several notations, and that can look confusing. As I've mentioned, the first notation is the f prime. F prime means the derivative is defined by this particular limit. Now, f prime of x can also be sometimes written differently, such as if you say y equal to fx, then the f prime of x is also written down like this. It's also written down as dy by dx. It's pronounced dy by dx, but this is not a fraction, well, per se. This is just a whole notation. And sometimes it even written down as this, dx of f of x, because f of x stands for y, in here. So any one of these notations are very commonly used, and you just have to remember that dy by dx is not a fraction, and that is the derivative. And the limit concept is simply to show you how we derive at it, but eventually we will memorize various formulas of how to take derivatives so that you don't have to go through the limiting all the time.